Let's look at this set of points, bind them with lines, set a number to each one. Greetings! It's a mathematical graph. Points are called vertices, lines, edges. Imagine a map where vertices are localities and edges are roads with given length. What is the shortest path from A to K? Let's ask the program. Now all the tracks are in our hands. Let's look at the electric circuit that has similarities with the graph structure, so the program supports it. Capacitors, inductors, resistors, switches, direct and alternating current. The interface has only needed for student functions. Now let's take electrostatic. Thin lines of 1, 2 or 4 charges are simple enough to draw them on paper. But what about more? Here graph comes to help. The next part of physics is waves. Have you seen what happens when waves cover each other? They make a wave picture. This process calls interference. Graph knows it. Let's assume that vertex is an object that has weight and that these objects interact with each other using a gravity field. We have a simulation of gravitation in the macro world. But what about micro one? About molecules? They also attract each other, but as distance between them reduces, this attraction decreases and then turns into repel. Graph allows simulating all these processes. Let's look at more advanced graphs with vertices that provide a limited number of particular edges and have different functions and parameters. Smoothly, we came to the most straightforward programming language that doesn't require code. The purpose of this mode is to teach young students to write programs and understand them. Let's look at the graph in which vertices and edges contain information such as text, photos, videos, music, presentation. Study maths, physics, IT, history, geography, anything you want. Use in school, at home, during distance learning, on interactive boards, check homework, conduct lab works. It's graph.